Welcome to Putting Together the Pieces Program 6. This program demonstrates coding dictionaries for lookup tables and storing those dictionaries in binary files that can be used later in another program. Write a menu-driven program that allows the user to translate text into Morse code and decode Morse code back into English text. Now, when we take a look at this program, we realize that we have two things going on. We need to be able to go from English text, or the letters of the English alphabet, to Morse code translation, and we need to be able to decode Morse code back into English letters. So we're going to use two dictionaries to do this. The first dictionary will use the letters as key and the Morse codes as values. So it will have the form of A for a key with a value of dot dash, B for a key with the value of dash dot dot dot. We also need a way to go from Morse code back to English letters. And so we'll build a second dictionary with the key, the Morse code, dot dash, and a value of A, dash dot dot dot, key with value B, and so forth through all the letters of the alphabet. The idea with binary files, like text files, is that we're creating persistent data. The data in these files can be used over and over again by different applications. The data is called persistent because it lives on beyond the time your program is running. So we will create persistent data files that hold the dictionaries to encrypt and decode Morse code. Putting together the pieces program 6A will build the lookup table dictionaries to make our application easy to implement and provide us with stored dictionaries as binary files for reuse. Here is a high-level design for our main function. We need to produce the alphabet letters to Morse code dictionary, then save that in a binary file. We need to then create the Morse code to alphabet letter decoder dictionary and save that in a binary file. Here is a structure chart to complete the process. The main function will call three other functions. The create Morse code encryptor function, which will produce an alphabet to Morse code dictionary. It will call the create Morse code decoder function that will produce a Morse code to alphabet letter dictionary. It will call the create binary file two times, one for each of these different dictionaries. That fourth helper function, print dictionary, can be used by create Morse code encryptor and create Morse code decoder functions to neatly print out the contents of the dictionary. Here we see the revision to the structure chart to include the data flow. Create Morse code encryptor function will produce a dictionary output that main will use when it calls the create binary file. Main also will call create Morse code decoder function, and that will produce as output the Morse code to letter dictionary that main will pass to create binary file. Morse code encryptor and create Morse code decoder will use the dictionary function to neatly print out the contents of the dictionary line by line. Putting together the pieces program 6A will build the lookup tables for encrypting and decoding Morse code, and then save them in binary files. The code is already written. Let's take a look. This program builds two binary files from dictionaries designed to provide an application with the ability to encrypt text as Morse code and/or decode Morse code into text. Topics demonstrated are dictionaries, object serialization using the standard library module Pickle, reading a binary file or loading a binary file into a dictionary, creating a dictionary with keys and values reversed, we see that our program is organized into manageable subprograms with main as the driver, and our functions are written and designed for reuse. We have create binary file being used 2 times in this program, and print dictionary being used 2 times in this program, called from different functions. The first line of actual program code calls the import pickle to be used to generate the binary file. Function main is responsible for calling the function to create the Morse code encryptor dictionary. The results of that will be stored in dictionary named MC_encrypt. Then main asks the user to provide a file name for storing that dictionary. Next, it calls create binary file with the file name given by the user and the dictionary MC_encrypt. After that file is created, the create Morse decoder uses that same file, reads in the contents, puts it in a temporary dictionary, and produces a new dictionary with the key and value reversed. We store that in MC_decode dictionary. Then main asks the user to give a second file name for storing this dictionary in a file. And main calls create binary file with the new file name and the new dictionary. Before we run this, let's take a look at the folder where the program is stored. Notice we have the program file and a few other files, but we do not have any binary dictionary files stored here yet. Looking at the create Morse code encryptor function that builds the alphabet letter to Morse code dictionary, we see the first line of code builds the dictionary. I purposely omitted letter U just so we could see how, if we needed to add to the dictionary, we could. The dictionary is enclosed in curly braces and has a key, a colon, and a value. Each one of those items is separated by a comma. The alpha to Morse code dictionary then assigns the Morse code for key value U. Now, if U had already existed, it would be overridden. But U was omitted from the original set here, and so that just adds it to the dictionary. Then we have 3 print statements. The first one shows the length of how many items are in the dictionary. The second one will show the minimum key value, and the third one shows the maximum key value. Let's run the program and see how it behaves. So after we build the dictionary, we see those 3 print lines. The decoder has 26 letters coded. The decoder min key is A, and the decoder max key is Z. We are not going to be able to use min and max with the Morse codes. So although this works with the keys A through Z, it would not work when we build our second dictionary with Morse codes as the key. After the 3 print statements, we see a call to the print dictionary. Alpha to MC is being passed into that function to print the contents of the dictionary in a neat format. I'm going to scroll down and we'll take a look at that code. For key in the dictionary, print the key and its value stored at that particular key. So one after the other, this is printing out the items in the dictionary. These items are not in alphabetical order. They're not in the order that we inserted them. And if you look carefully, you'll see that U is not the last item either, even though we put it in after we built the rest of the dictionary. This is because dictionaries are not stored in our traditional ordered fashion. Behind the scenes, dictionaries do what's called a hash to store the values randomly. And so there's no discernible order to this. If you need a data structure that relies on ordering, then it's wise to use a list. Now the program is asking us to name the file for storing the MC_encryptor dictionary. So let's go ahead and type in a name here. Let's call it letters to mc.dat. We enter that and the program continues. We are now at the Create Morse Decoder function in the code. After building the decoder dictionary, it's time for us to reverse the keys and the values. So we read back the file, open that file, notice the RB for read binary. We load it into a dictionary that we're calling temporary Morse Code dictionary. Notice that it's set to pickle.load in B file. Now in B file is the name of the variable that we're using. So throughout this function, when we want to refer to that particular file, we're calling it in B file for input binary file. After we load it into the dictionary, we then close it. Next, we have 3 print statements. The first one says, here are the contents of the binary file. We see that in the output file. Then we print the dictionary. Again, this is not going to come out line by line because we just said print dictionary. It just prints the contents with each item separated by a comma. But you can see the beginning brace and the closing curly brace. And to be able to look at this in a neater fashion, we build our second dictionary that's going to use the Morse code as the keys and the letters of the alphabet as values. So we see that line of code, MC to alpha. Look at that line carefully. Let's dissect it. We're going to look at each item in the temp Morse code dictionary, and for each key comma value in that temp Morse code dictionary, we're going to build a new dictionary with the value from the key and the key from the value. Next, we print that out using the print dictionary function, which puts them out neatly on the page. Again, they're going to be in an order we don't understand, and it's not even going to be the same ordering that we saw for the original dictionary. We're not really concerned about the order. The whole goal here is to be able to quickly look up something based on the key value. Since we want to do a translation of Morse code to English text, it will quickly find the correct letter given the Morse code. Right below Create Morse Code Decoder is the Create Binary file. This was passed as input a file name and a dictionary. The out B file will be the name of the variable we use within this function to refer to the output file. We initially open it, and if it's not there, it will create it. The format is write binary, so we see the WB being passed in as a argument. Then we pickle.dump the dictionary into out B file. So when we were using text files, we did a read and write. Here with pickle, we're doing load to read in and dump to write output to the file. If we take a look at these files, which we'll do in a minute, you will see they're not text files. They're hard to decipher because they're in a binary format. Okay, and then we close the file. The program is still waiting for us to type in a name for the decoder dictionary, so let's do that. Let's call that mc2letters.dat. And again, I'm not using a txt here because these are not text files. And the program's finished. I'm going to minimize that. And here now in our folder, we see that those 2 files have been produced. Letters to mc.dat and mc2letters.dat. And just to get a glimpse of this, let's try to take a look at it. Yeah, doesn't look too good, right? Again, it's stored in a binary format, not really meant for human eyes. I'm going to close that. So just to recap, dictionaries and binary files. There's no doubt about it. Python provides us with some sophisticated tools. Built-in data structures include the list, tuple, dictionary, and set. It also provides us, through the standard library, easy mechanisms for saving data and information in files. This is called persistent data because its lifetime extends beyond the time a program is running. Remember, you are not expected or even encouraged to memorize all of the features surrounding the sophisticated programming tools supplied by Python. The important thing is to get a sense of their purpose and usefulness when solving more complex problems. At this point in your careers, what is important is to know what you can do, not necessarily how you would implement it. Those skills come with practice and experience. Happy coding!